Hi, everyone. Welcome to the Engineering Insights for V022 of the Hedera services. And today we're going to cover HTS Pre-compile, which is a huge component of Smart Contracts 2.0. My name is Ed Marquez, and I'm a developer evangelist at Hedera. And today, Simi Hunjan, who is a developer advocate, is with me to present some of these topics. Hi, Simi.
Hey Ed, how's it going?
It's going great. How are you?
Awesome. So let's talk about what HTS Precompile is. HTS Precompile is the ability to call Hedera token service transactions in your Solidity smart contract. We currently support 5 transactions today: transfer, mint, burn, associate, and dissociate. As well as in this release, we increased some of our gas limits. So we have a 15 million gas per second system-wide throttle. We have a 4 million gas per second throttle on our ContractCreate and ContractCall transactions. And we also have increased the contract size limit to 10 megabytes. Where can you find these supporting Solidity libraries? We did create a repo under the Hashgraph organization called Hedera Smart Contracts. And within that, you'll find an HTS precompile folder where you'll find these 3 supporting Solidity libraries. The 2 that might be of most interest to you will be the Hedera token service one and the Hedera response codes one. And here's an example on the right. So if you open up Remix or whatever Solidity editor that you're using to write your contracts, you'll use the import and you'll import Hedera token service. And you can also optionally import Hedera response codes if you like that to call functions from that contract into your contract that you're writing.
Cool. Simi, I had a question here. So first, it's great to see that the throttles were increased. That's something that a lot of our users were asking about. So it's definitely good to see that. And then the question I have is for those people who are not too familiar with the token service, what are some of the other transactions that will be added to these HTS precompiles later on?
The other token service transactions that will be added in the future will include token create. That's something that we're looking at for an upcoming release. And then there's a handful of other token service transactions like token wipe, adding KYC, removing KYC, and things like that. All of those Hedera token service transaction types will be added in the future as well. So you can think of whatever Hedera token transactions we have on Hedera, you will also be able to use in your Solidity contract itself.
Cool. Glad to hear that's coming. And then as these libraries, change and functionality is added, how are these changes going to be communicated going forward?
Yeah, so as far as new support for precompile Hedera token service precompile transactions, you can always refer to our release notes on the services page. You can also visit the Hedera Smart Contracts repo, and that should also provide documentation for any new support or changes that are made to these files.
Awesome.
Okay, so moving on to the next slide. Here's an example of how you may use the supporting libraries in your Solidity contract. So for example, you can see here, you have Hedera token service .associate token, and this allows you to associate a token through your smart contract. I also wanted to bring up a note of what the address field maps to in Hedera. So an address in Hedera is like the account ID or token ID or really entity ID that you have on Hedera. So the address that you would put here for like the sender would be the account ID, and the address for the token address parameter, you would input the token ID. So in this slide, I wanted to cover the parent and child transactions and how that relates to HTS precompile. A parent transaction is a transaction that executes a subsequent transaction that the user may have not directly specified. So in this example, you can see that the contract execute transaction is a parent transaction. And down below, where you see set function, where you're calling a function of the contract itself, in this case, it's a token transfer transaction, that is the child transaction. So if you want to get information about the child transaction, you will have to use the parent transaction ID. And then for records and receipts, you'll have to note to set the children equal to true so that you can return the corresponding child records for this transaction that was executed. You can also notice that the parent transaction, child transaction share the same payer account ID and transaction valid start time, and the only difference is the nonce value at the end. So, for example, in this case, the parent would have its standard transaction ID, and the child for the token transfer transaction would have the transaction ID with a nonce value of 1. If you're looking to find the transaction fees for the child transaction, you'll have to look at the transaction fees returned for the parent transaction in the record, because all of the fees for the subsequent child transactions are rolled up into the parent. You can see that above, I have this example in Java where you're submitting a Hedera transaction as a contract execute transaction. And down below, I have the example function that's being called in this contract execute transaction from the contract. So you can see where I have set function, I have token transfer as the name of the function. And you can see down below in the contract, it's calling this token transfer function here. So the parameters that you're providing, like the token ID, the account ID, and another account ID, are the same parameters that you see down here for this function. So you have the token ID, you have the from account ID, and then you have the to account ID for this token transfer. And this is how you would see it when you're submitting it to the Hedera network to execute that function from the contract that you wrote. And this is what I mentioned in the previous slide, where if you want to get the record or if you want to get the receipt of that transfer transaction that you called from your contract, you have to use the parent transaction ID and then set the children value equal to true. This will return a list of all associated child transactions that the parent transaction kicked off. And here's an example of the similarities and differences between what you'll notice between the contract execute parent transaction and the transfer transaction as a child transaction. So just going through the list here, you'll notice that the consensus timestamp for the parent is 1 nanosecond ahead of what the consensus timestamp is for the child. And this is because the contract execute transaction executed first, and then subsequently that triggered the execution of the transfer transaction. You'll also notice the transaction IDs. They are the same except for the nonce value that the child transfer transaction has. I mentioned this in the previous slide as well. And this is an example of the transaction fees where you'll notice that the child transfer transaction has 0 there for the transaction fee, but then you see the transaction fee populated for the parent transaction. So the parent transaction has the transaction fees for the parent transaction plus the child transfer transaction. Because the fees are rolled up into the parent and the transfer list of the child, you won't see any transfers listed there. You'll see all the transfers denoted in the parent transaction record. Because the child transfer transaction transferred tokens from one account to another account, you will see the token transfers list populated there. And that just represents the transfer that this token transfer transaction made. And then the last thing, in the child transfer record, you will see the parent consensus timestamp that is populated. This field is only populated for every child transaction. And this is so there's a way you can map like the the child transaction record back to the parent. All right, so existing contracts, you will not be able to use this for existing contracts because you will not be able to modify those contracts to be able to add or call these functions into those contracts. For existing tokens, you can interact with those tokens using HTS Pre-compile, and everything should work just fine. There's also some additional mirror node REST API support that was added for contracts. So you can see this list of APIs here, which includes getting information about a contract results, along with the logs. And so there you have these different options of returning that information. And you can find all this information on the doc site to be able to understand how to use them.
And one point I wanted to mention here about the second bullet is that a contract can manage certain aspects of a token. For example, the supply. If you set the contract as the supply key for a token, then that contract can mint and burn, right? Add and take out of the supply for that token. So those are the kind of interactions that this HTS precompiles enable.
Thanks for adding that, Ed. So I just wanted to go over like a high level of like what do you have to do to be able to use this feature, just so that it was kind of clear. So you're going to create your Solidity contract, and then you're going to call these supporting Solidity libraries into your project. You'll go ahead and compile your contract, get the contract bytecode, and store that bytecode on a file on Hedera, and then create the contract instance on Hedera. Then you can go ahead and use a contract execute transaction to call functions from the Solidity contract that you created in the previous steps. Cool. I'll pass it over to Ed to go over the demo.
Excellent. Thanks, Simi. And what I want to do here is just do a quick walkthrough of an example that has been documented via videos and also blog articles. And so I'll start by showing you the output of this example. And I'll go through the four key steps that you have to take when deploying smart contracts on Hedera. And so in the first step, I just have a message that says done. And in this case, we're importing the bytecode of our compiled smart contract. Then we create a token. We output the ID of that token in Solidity format. Here we also output the initial supply for that token. Then we create a file that contains the bytecode for our smart contract. There we see that the content for that file is added successfully. And then in step 3, we instantiate or create a smart contract on the Hedera network. There is the ID for that contract. There is the Solidity address for that smart contract. And these two fields are equivalent. Then I do a token query to check the initial key for the supply that we have for that token. And in this case, it's the public key of an account. Then we do a token update to change the supply key to be the contract. And in this case, this means that our contract is now managing the supply for the token. So it can mint and burn tokens. And then in the last step, we use our smart contract and different functions that are inside that contract to mint new tokens, to associate an account with a token, and then to transfer tokens between accounts. And so with that in mind, we can do the quick walkthrough of the actual code. So here again, we're importing or reading the bytecode of the compile smart contract into this variable. Then in step 2, we create a token with these attributes and properties. And in this case, the treasury ID is the treasury account for the token and also the admin and supply key. And later on, we update this key to be the smart contract. Here, we output some information to the console that you already saw. And next, we create a file on the Hedera network to store the contract bytecode. We do that with the file create transaction. And in this case, we start by creating an empty file, but then we append the content to that file, and the content for that is the bytecode that we read from the compile smart contract. So the next step after that is to create the smart contract on the Hedera network, and we do that with the ContractCreate transaction module. We point that to the file ID that contains the bytecode. In this case, it's that variable. And once that smart contract is instantiated, then we output this information, which is the contract ID and the contract address. Now, in this case, this method is of interest in this module because this is how we pass parameters to the contract constructor function to initialize state variables, for example. And then in this same step, step 3, then we do a token update. And the change that we do to our token is that we specify the contract to be the supply key for that token. So the contract, again, can manage that supply. And then in step 4, we basically call the 3 functions that are in our contract, which are token mint, token associate, and token transfer. And now we can take a quick look at the Solidity smart contract. So the contract that I wrote is called mint asso trans, HTS. And again, the constructor for the contract takes a token address, which is the one that of the token that we're working with. And then there are the 3 functions that we'll be calling. And so this is the function that we call with the contract execute transaction module from Hedera. And this function in turn uses the precompile contract. So it's basically using accessing this mint token function in the precompile contract. And if we want to take a look at the inputs and outputs of this function, we can actually do that by looking at that precompile contract. One thing to mention is that it's necessary to have these files in your working directory, the precompile libraries, and you see them here. So now if we take a look at, for example, that mint token transaction or function, you see that it takes the token address as an input, the amount of tokens that you want to mint, and if you're working with NFTs, it also takes some metadata. And in this case, it returns a response code, the new total supply for the token, and then the serial number, again, if you're working with NFTs. So understanding those inputs and outputs, that's how we write this mint fungible token function here. And these response codes that you get in return can be helpful for creating some logic or tests here in Solidity based on that response. And you see that this is using that Hedera response codes precompile contract as well, so that you can do some of this logic and testing. And that's the same case for the token associate function and the token transfer function. You would have to look at the precompile contract to understand sort of the inputs and outputs that are needed to work with that function. And that's basically how we call those in this index.js file. So if we look at the mint function in more detail, you see it's a contract execute transaction module. And with this set function method, we're calling that mint fungible token function that you saw here. And we're passing a new a function parameter that is the amount of tokens that we're going to add to the supply. Then we do a token query to make sure that we actually added those newly minted tokens to the supply. And then we do the token associate function, which you see here in this set function method. That's the function we're calling. And we're passing the inputs that that function needs, which is the address or the account that we want to associate with the token. Then we sign, execute, get a receipt, output some information to the console. And the last step is to do the token transfer. And if you remember, if we look at the token transfer, it requires the sender address, the receiver address, and the amount of tokens that we want to send. So that is what we pass in these contract function parameters after calling the right function. So the sender address, the receiver's address, and the number of tokens to transfer. So in this case, we're sending tokens from the treasury to Alice. Keep in mind that the treasury has to sign that transaction, right? Because tokens are coming out of that account. Then that's executed, that transaction is executed. A receipt is obtained with the Hedera client, and then we output all this information that we saw in the console. For example, the confirmation that the new tokens were added to the token supply, that Alice's account was correctly associated with the token, and then that the transfer was actually successful. And since we had a total balance or total supply of 250 tokens, after transferring the 50 to Alice, 200 remain in the treasury, and then Alice received the 50 of the token that we just created. So that is the example or the walkthrough that I wanted to go over with you. And I want to show you where you can get these precompiled libraries. This link will actually be available in the video description, so you can get that there. And these are also accessible from the documentation and the release notes. And if you're interested in going through the example that I just walked through in more detail, you can find this article which actually details everything you need and the steps needed to deploy a smart contract on Hedera and gives you more background information as well. And you can also watch the video tutorial if you're interested in that. And another important aspect of working with smart contracts on Hedera is getting or being able to get event information from those contracts. And if you're using events in your contracts, there's two ways to do that. That's with transaction records and also with mirror node. And so I encourage you to check out this article if you want to be able to decode the topics and the data that are included in events when you write or use events in Solidity. Simi, do we have any other topics to cover today?
Not other topics, but I did want to maybe make a couple of points if you can go back to your coding sample. Just because it was a couple of things that I know I had stumbled upon when I was going through an exercise with this. But one of the things that I wanted to note here was that for any of the precompile functions that you call, if it requires any signatures, you have to provide those with the contract execute transaction. So I think, for example, you had like token associate and you had token transfer, where in token associate, the owner of the account needs to sign. And for token transfer, any of the accounts that are being debited need to sign that transaction. And so just wanted to like highlight that because sometimes that can be missed because you're signing in the contract execute transaction, but you're calling that function from like the contract itself, but you still need to sign with the appropriate keys for it to work.
That's a great point. Yep. Thanks for adding that, Simi.
Yeah, and the other point was just that make sure that when you're calling the function parameters that you provide them in the order that they are listed in the function that's written in your Solidity contract. If you provide these out of order, it will fail and it will not work. Yeah, that was just something that I stumbled upon myself as well.
Awesome. Well, thank you all for joining us for the webinar. I encourage you to join our Discord server to be part of the technical discussions and understand the questions that users are running into, and we'll be there to help you as you develop your applications. With that, thank you everyone, and thank you, Simi, for this excellent overview.
Yeah, thanks so much, Ed. Appreciate it.